Been doing a lot of stuff with parallel lines and transversals, lots of proofs. You won't see any real transversals here, and you won't see any proofs. So this is just a nice kind of really an algebra review lesson. Our final two learning targets: write equations for lines that are parallel or perpendicular to a given line through a point. So we're going to be using some substitution to do that. And then the final learning target, number 12, determine whether lines are parallel, perpendicular, or neither. And we'll find out in a second how to do that using slopes of lines, which is something that we've been reviewing quite a bit here recently. All right, so first things first. Two things that you need to know about parallel lines and then perpendicular lines, and specifically dealing with their slopes. So the slopes of parallel lines are the same. Okay? If I were to take a look at two equations, y equals 2/3 x plus 1 and y equals 2/3 x minus 5, I would be able to tell right away, without even graphing them, that they're going to be parallel because the slopes are both 2/3. If I were to graph them both out, certainly, well, you got +1 is my y-intercept, and then 2/3 up 2 to the right 3. So up to right 3 would give me something that looked kind of like this. And then the second one, -5, is a y-intercept, 1, 2, 3, 4, 5. So I'd start here, but I would have a slope of 2/3, so up 2 to the right 3. And you can see here that, well, sure enough, I have lines that are parallel. So when I have equations and their slopes are the same, that means they must be parallel. Now, the other big thing that we've been working with, in addition to parallel lines, is perpendicular lines. And this one's got a little bit more to it. The slopes of perpendicular lines are the negative inverse. What in the world does that mean? Well, here, let me give you an example. If I had a slope of 2/3 in my original one, well, negative means that it'd be the opposite. So like the opposite of positive 2/3 would be negative 2/3. But I also want the inverse. So this is just the opposite. I want the opposite, or negative inverse. So this isn't quite it. I would still have to go from positive to being negative, but inverse means you flip the fraction upside down. So 2/3 would become 3/2. -3/2 would be my inverse, negative inverse. Okay, so these two things would be perpendicular. So like, let's say I had -4. What would be the negative inverse of -4? Well, the opposite, or the -4, would be +4. But this is -4/1. So I would want to switch it, and this would become 1/4. So negative becomes positive, 4/1 becomes 1/4. Okay? And if we wanted to take a look at this, let's use the top one here. Let's say I had y equals 2/3 x plus 1. If I had y equals, and you use this one now, -3/2 x, plus 4. Okay, let's see how these shake out when I try graphing them. Well, first one again, y-intercept of +1, and then slope of 2/3, so up 2 and to the right 3. So here's my original equation or function. And then here, +4, 1, 2, 3, 4 would be right up here. And then I'm going to go down 1, 2, 3/2. And when I connect these two, you can see that even though my drawing is really rough, that makes a perpendicular line. All right, well, let's see how this looks in some examples. What is the equation for the line parallel to y equals 4x minus 2 that goes through the point -2, -2? All right, well, because it's parallel, I know that the slope has to be the same. The slope is 4, which means the slope in my new equation must also be 4. So y equals 4x, and I'm just going to put plus b. I don't know what the y-intercept is. That is something I have yet to find. Now, do I have a way of finding what the y-intercept is? Well, right now I have too many variables to solve for b, but do I have anything that I could maybe plug in for x and y? Well, sure I do. -2, -2, that's an x value and a y value. Let's go ahead and plug those in. Y is -2 equals 4 times x, which is -2 plus b. Well, sure, now I can solve for b, no problem. 4 times -2 is -8. And how do I get b by itself? Well, the opposite of -8 is +8. I add 8 to both sides, and I wind up with b is equal to +6. Now don't stop here. It didn't say what is the y-intercept. It said what is the equation. So I'm going to take this 6, and I'm going to take it and plug it right back in here. So my final equation is y equals 4x plus 6. So I know that this is parallel to this one because they have the same slope, 4. But this one goes through -2, -2 because if I plugged in -2 for x, -2 would be y. All right, let's move on. Here I've got a situation where I want a line that's not parallel, but a line that's perpendicular to this function, and it contains the point 6, 2. All right, well, let's see. Perpendicular. My original slope is 3. So how does that change things? Well, positive is going to become negative, and 3, or 3 over 1, is going to become 1 over 3. My slope of my new line is -1/3. So -1/3 times x, again, plus b. I don't know what my y-intercept is yet that makes it go through this point. Well, just like last time, I need an x and a y value in order to solve for b. So make sure that you're real careful here. The last time they were both the same number, so really you couldn't mess it up. But a lot of students accidentally put this number in for y because it comes first, but know that, well, y is actually 2, so concentrate a little bit. Put the 2 here, and then the x value is 6, so that goes in for x plus b. All right, well, let's solve for b now. -1/3 of 6 would be -2. And to get rid of that -2, I'm going to have to add 2 to both sides. And so now I'm left with b equals +4. Ironically, a lot of students accidentally go back and use the original slope at this point. Don't do that, okay? Use this slope. This is the one that we wanted. You're just taking this 4 and plugging it straight into this guy. So y equals -1/3 x plus 4. And that is how I write an equation for a line that's perpendicular. All right, let's see, the last thing I believe. So two things. This is your last learning target. Show whether the lines are parallel, perpendicular, or neither. Well, I'm looking at it, and they're definitely not parallel. But are they perpendicular? Maybe. They kind of look like they could be. How could we tell? Well, you got to kind of go back to the good old days when you were able to find slope. Slope is going to be rise over run, or y2 minus y1 over x2 minus x1. Okay, so let's see. If I found the slope between these two, again, I probably could just count if I really needed to. Sorry. Okay, I probably could just count if I needed to. And so I'm going down a whole bunch, and then I'm going over 3. So down 2, 4, 6, 8, 9. So down 9 over 3, which would be -3. But if I wanted to use my formula, I could certainly do that. Y minus y, so 5 minus -4 over negative 2 minus 1, which get me 9 over negative 3, which is still negative 3. So you can use the slope formula. You can count if you need to. So let's see if my other one is positive 1/3, well, then they're going to be perpendicular. So let's go ahead and try that out. If I go ahead and start just counting, well, let's see. I rise 3, run 3, 6. Rise 3, run 6. I think that's 1/2. That's not 1/3. And again, if I use my formula, I go 4 minus 1 over 2 minus negative 4. That's 3 over 6. That's still 1/2. Okay, and negative 3 and, well, 1/2, those are not the negative reciprocals or inverses of each other, so I go ahead and say no. All right, last one is essentially same type of question, but without the graph. And so I look at it and I think to myself, well, what are the slopes of these things? Because the whole thing is keying on the slope. And I look at it, can I tell the slope in standard form? Nope. So I'm going to have to do that whole trick where I convert it. So let's see what we got here. I'm going to subtract 2x from both sides. And that leaves me with not 7y, but negative 7y. Don't forget about that negative sign there. And then to kind of keep it in slope-intercept form, I'm going to put the negative 2x in front. All right, divide both sides by negative 7. And what I wind up with is y equals positive 2/7 x plus 6. Really, all I'm concerned with right now is the slope. So 2/7. If it's going to be parallel, they're going to be the same. If it's perpendicular, it's going to be negative 7 over 2. Anything else, it's neither. So let's go ahead and solve this one for y. I've got 4y equals negative 7x minus 2. I guess for this one, all I need to do is divide by 4. And so I wind up with y equals negative 7/4 x minus 1/2. Well, negative 7/4, that's close, but not quite. I needed negative 7 over 2. 7 over 4, not the same thing. So, no, these are neither parallel nor perpendicular. All right, that wraps up chapter 3. Hope it was a good one for you.